Hey, this is day 20 of 100 Days of Code in IoT Challenge. My name is Thomas, and today I'm going to be downloading the file from the internet on ESP8266 over HTTPS protocol. That is secure and recommended way when you're building an IoT device, although it is a bit more complex. And by the way, if you just want to download the file using HTTP, have a look at my previous video, link in the description. Again, today there's not gonna be any other hardware parts except for ESP8266 itself and USB cable to connect it to my computer, so we can move to the code now. Okay, and let's do HTTPS example now. So again, I've got a fresh main.cpp file, just initializing the serial monitor, and we have the delay for 5 seconds for the serial monitor on IDE to be able to catch up with the device. Don't forget about PlatformIO.ini configuration file changes, setting the monitor speed for the same value as we have in the serial begin. And also board build file system is fs, because that's the file system I'm using in these examples. Okay, and one more thing is the library, the core library I'm using. You can clone it into the core library inside the core directory inside the lib. There is a command in the description of the video, but I'm going to demonstrate. So it's this command that you are supposed to run inside a core directory to be able to use my library with the Wi-Fi manager and the SingleHostHTTPSClient, which is going to be the main class that we're gonna use today. Okay, so yeah, I've got everything prepared. So the core library installed and the initial code in the setup is done. So now, first of all, I'm gonna go back to Arduino IDE, and there is an example we are interested in, which is the HTTP client stream HTTPS client. It is this one, and that is the piece of code that is doing the reading from TCP stream, which is basically the HTTPS is on top of it. And there is lots of implementation details here, which I'm going to hide today by modifying SingleHostHTTPS client that I've built as a part of my library. So we're gonna have a quick refactoring session, very quick one though. If you don't want to watch the refactoring session, you can skip it to the next section on the video, because the video is split in different parts. And also I'm gonna at some point there's gonna be a time you can forward to on the video on the screen if you want to skip the refactoring session, right? Because I don't want to write all of this. What I would like to do to read from the body stream, from the response body stream, is to use only while available method, and then just read bytes inside without or keeping track, of something like len and stuff like that. Obviously, this bit also is going to be there, but that is going to be where we write to the file. But yeah, anyway, let me show you how that should be done. So what we're gonna need is the SingleHostHTTPSClient. So yeah, first of all, I need to add some includes. So we need Wi-Fi manager, event dispatcher, timer, and then we need the SingleHostHTTPSClient, right? And what I'm gonna do is to create instances of those classes. So we will have dispatcher, we will have timer, Don't forget about putting a line inside a loop function for the timer to tick. I'm gonna refactor timer soon to remove this again. This is for me, like, you know, I see it as an implementation detail. It shouldn't be required for the developer to do that. So I will try to find a way for the timer to do it automatically internally, like in the class. But yeah, for now, we're just gonna have to do it. And then a Wi-Fi manager is the next one. Wi-Fi manager. And Wi-Fi manager requires credentials. So SSID and password. So that will be the Wi-Fi, local Wi-Fi, home Wi-Fi credentials, the name of the Wi-Fi, my SSID. SSID is the name of the Wi-Fi, and password is a password to the Wi-Fi. And for the Wi-Fi manager, we're going to need to provide some values. There was SSID and password, but also there is some additional one, but I can't remember what was the order of it. Okay, there is Wi-Fi multi, dispatcher, and timer. So dispatcher, and timer, and one missing dependency, which is the Wi-Fi multi, and that also needs an instance, right? So 8266 Wi-Fi multi. That also needs, the Wi-Fi manager also needs a pointer to. So Wi-Fi multi is the first one, right? This is for setting the SSID and password. Okay, so the setup is done. And now, the most important class that I forgot about, which is a SingleHostHTTPSClient. I'm just going to call that variable that's gonna keep the instance of it, HTTPSClient, and that needs, again, there is a few things that are needed. So there is host, certificate, Wi-Fi manager, and timer. So that's gonna be host, that's gonna be certificate, Wi-Fi manager, and timer. Okay, so for the host, let me just find that. So for the host, let me show you. I have opened it already in Firefox because we're gonna need the certificate as well. This is gonna be the host. It's still the same server, which is essentially S3. That actually doesn't work with, doesn't work like that because this is not a S3 server. This is just the way to access the file straight away. The big txt file, HTTPS. So yeah, we're gonna do the big file straight away because, you know, this solution is gonna work well with the small files, right? So that's gonna cover all the cases, not just small files, right? So that's gonna be the URL. However, SingleHostHTTPSClient doesn't need, actually requires us to pass only the host, only the domain. So without protocol, without the path. The path is gonna be useful later. And certificate. So certificate in Firefox is quite easy to obtain. You just need to click on the padlock, on the arrow here, more information from the new window, view certificate button. Then we need the right certificate, the one on the right? And we need to download it. The PEM set, this is the one that we're interested in. And what I'm gonna do now is I'm just going to a downloads folder and I'm going to just open it here in the VS Studio Code. And let me show you how this is done, because that's gonna be multi-line. So I actually have this already pasted as a const char. Let me just paste it in. So that's how it's gonna look. It's the same certificate. I just prepared it beforehand. And because this is a multi-line string, I'm using this notation. And also this is gonna live on the program memory, not on RAM, right? To save the RAM memory, essentially, it is quite big. Okay, great. So certificate is passed. Then we have the host. And what we could do is to just call the HTTPS client and call the method sendRequest that requires us to pass the request struct, which is very primitive. It just takes a path, right, which is going to be this bit, right? This is the path of our URL. Okay, if you don't have it, if it's just if it's just a URL without any paths, there is nothing after this bit, right? So you have like .com or .co.uk or something like that. You would pass here just slash. That's it, right? The path is required. So don't pass nothing, because I'm not sure what the behavior would be. Okay, and the second argument here is gonna be the callback function, and that callback function is going to take a response, and that response at the moment is incomplete. I'm gonna have to modify the way sendRequest works, because if we click through on the response, and yeah, this is where the refactoring begins. So that will be the moment where you would probably like to skip it straight to the usage of sendRequest or of the improved sendRequest. What I can tell is, before you skip this part, is that the response at the moment, if we go to the SingleHostHTTPSClient, it has a body as a const char, as a C string. And my goal of the refactoring is to turn it into a stream. So we will be able to read from it like we read from the file, using the while loop with available method and the read bytes, right? So that's the goal of refactoring. And you can skip now. And yeah, here I'm just gonna continue on the refactoring. So like I said, we need to improve the response struct to take the stream, to actually have a stream here instead of const char on the body. So essentially, that line where we retrieve entire payload as a string is not gonna stay here, because we probably, if we had like with the big file I'm actually trying to do this example with, that wouldn't work, because we would get the empty string or something like that. Something like when we tried yesterday reading the entire file in a single line, right? And write it to a string at once, right? We got the empty string instead. So this has to be done line by line. And this is also where I'm going to try to adapt that solution, which has lots of implementation details, into the code here. In order to do that, I'm gonna have to define my own stream, right? This example relies on, let me show you, it relies on reading the bytes from the client, and that client is this one, right? Is the bare SSL Wi-Fi client. It's essentially a TCP client, and it is based, I've got the same thing here, Wi-Fi client secure, and it is based on Wi-Fi client, and Wi-Fi client itself is based on client, and that client is based on stream, which is very similar to what we do with the files, right? We also read it as a stream. We have the same methods. We have available, we have write read. There is also read bytes, but yeah, on this one there is not. We're gonna define it though. Cool. So let me just close those header files, and for that, what I can do is simply create a new class. I'm gonna call it body stream. It's going to inherit from the stream. Okay, and let me just quickly define public constructor and public destructor. And I'm going to create an instance of it. I'm gonna create an instance of it, but before that, let me just change the body to body stream. So body stream. And here, this is where we try to pass the payload, which is no longer gonna be the case. This is where I'm going to create an instance of body stream. I'm just gonna call it body, that's fine. And that's what we're going to pass as a pointer, right? Just address to it. Okay. And I'm gonna try to compile to see what are the required methods that we have to implement. I could do it also by looking at the stream class, but this way is going to be a bit faster. So, because those virtual methods, these are the methods that we need to provide. So we have size Steve write, that's one. Then there is available. This one I'm gonna put on the top because we actually going to do our own implementation. Read one. And pick. Okay, now it's just warnings because we don't return any values. So yeah, these are the required methods. I'm going to add read bytes as well, but give me a second. Let's have a look at this example again, and how do they read from the response body stream. So in this while loop, they check for HTTPS, which is a HTTP client, if it's connected, and they also do client available. Right, there's also get size method, so it looks like it's the best way of dealing with it, hiding all those implementation details, would be to make this body stream extending the Wi-Fi client. Right, so this client, let me just show you, Wi-Fi client secure, right, which is essentially derived from the Wi-Fi client. We want to extend it through the composition, and HTTP client is also going to be required because we need to check if it's connected. So sort of like this is the subject here. We're extending Wi-Fi client, secure Wi-Fi client in general, but the HTTP client is also needed there. So I'm going to define those classes, mainly pointer to those objects, right? As a required variables in the constructor. I'm gonna set them as a class variables as well. So you know what? Let's just maybe Wi-Fi client is just gonna be Wi-Fi client, but HTTP client I'm just gonna copy here, and these are gonna be public, private. So we have HTTP client, and also there's gonna be Wi-Fi client because I'm interested in the base class of the Wi-Fi client secure, and that's gonna be called Wi-Fi client. And this is also what I'm going to take in the constructor. This one is the subject, so it's going to be first. This one is the supporting one, which is gonna be the second. And I need to assign the values here. So Wi-Fi client is Wi-Fi client, and HTTP client is HTTP client. Right. Okay. So yeah, so that's one thing. I'm gonna have to also pass the pointers here. So the first one is the Wi-Fi client, which is called client here. That's client, and we have HTTP, which is the HTTP client. Okay. So now go back to the example, and so we're checking for the connected, but that happens in the while loop, which is going to be sort of like, yeah, this is essentially gonna be our available method, because that's what I would like to have outside of the stream, like for the client of the stream, the consumer of the stream to do while body stream available. That's it, right? So this is gonna be the condition we will have inside the available. And that uses HTTP client available. Come on, available. There is such a thing. HTTP client connected. And we also have len. And len is something that is at the beginning, it is a HTTPS get size, right? So this is the size taken from the HTTP client, and then you can actually notice that in the while loop, if the len is not -1, which is when the content length header on HTTP set to -1, so this is when we don't know how long is gonna be the stream of data. But for all the other cases, when we actually know what is the length, it is subtracting the number of bytes read from the stream. So we're gonna need something like that, something similar in our class that is hiding all those implementation details. So what I would do is to copy that line and do it in the constructor. Not this line, hang on. Copy this line. Do it in the constructor, but that would be a class variable. So len would be a class variable. I don't really wanna this video to be too long, so we're just gonna go with the simplest way of doing this, of implementing this stream. I'm not actually even sure if it's possible with the Wi-Fi client as a stream to like read it more than once, but this is essentially gonna be what's gonna happen with our body stream. You will be able to read it only once, right? This is this HTTP client get size. So we get the size at the beginning, okay, and now we have the len, which is the actual size. I might rename this variable later on, but this is okay for me. And here, what I'm actually gonna do is to check for the opposite. Have a look at this one. Let's have a look at this one again. And while HTTP connected, so only if this condition is met, if it returns true, it is going to continue. Okay, otherwise that's gonna be 0. And this is how I'm gonna start. I'm gonna turn this condition around. So if it's not connected, or it is not greater than 0, or it is not -1, so we just left with equals to 0. So we can simplify this condition actually. So that be this len equals 0, if this happens, to be honest, we actually don't even need if this len 0, because if the len is 0, we can return len. This is essentially what I want to do anyway. So for this one, it's going to be 0, and then we're just going to return len, because len is going to be essentially the number of bytes left to read from the response body stream. Okay, yeah, so we've got this covered. For the write, I'm just going to return here what's coming from HTTP client write, which is it really gonna be the case? I think we should be able, oh, sorry, that's not gonna be HTTP client. From the Wi-Fi client, this is the one that we extend here. And I've just actually realized HTTP doesn't seem to be a stream. There is an overload for that, I'm pretty sure. So yeah, we need to define this as a buffer maybe. And that buffer is going to be passed. I would probably need to implement all of those overloads, but I'm not gonna do it now. This is just gonna return this Wi-Fi client read, and pick is just gonna work the same way. As I said, there is some additional work that needs to be done to make this stream compatible with the underlying object, which is the Wi-Fi client, the one that we're extending. But I'm not gonna do it during this video, because that's gonna be too much work. We are only interested in available, and we also need read bytes, right? We would like to have something exactly like on the file, working with the file system. So something like, read bytes. I've got prepared not the body, just the definition of this method. So that's gonna return size t, and it takes the byte pointer to the buffer and the length. Okay, and this is essentially going to be the main method we're going to focus on, where all of this happens. Okay, all of this happens, but I'm going to modify it because I don't think all of this needs to be implemented in this way, since we know what is the size, the number of the bytes to read, except for the case when we don't actually know, which is when it's -1, but I'm gonna have it covered. So again, anyway, for read bytes, we need to make sure we can read those bytes. So len is gonna help us. It shouldn't be different than 0, right? If it's -1, we should keep reading. That's fine. If it's greater than 0, that means there is still some bytes left on the stream to read. So that's gonna be one thing. And then I'm gonna actually read bytes from Wi-Fi client, because this is what I'm extending, right? I'm extending this method that needs buffer, and it needs also length. However, with length, it is a bit tricky, because what if someone provides greater length than we have left on the stream to read? We probably want to provide the other value, which is the number of bytes left, right? If it's essentially less than length, right? Otherwise, we may end up with some weird characters at the end if we read text. If we read something else, we could corrupt the entire file. So here, I'm going to use std_min. That is a method that essentially you provide two values, and it's going to return the minimum one, right? So the one that is smaller. I need to cast it to size t though, because this is essentially, I could do it the other way around. So cast length to int, because let me just show you. So we have len as int, right? And length here is size t. So that's why I had to change that, right? Size t is unsigned. Cool. So that's gonna read the bytes with the appropriate length, right? So it's not gonna read more than is required. And here also, I need to cover this. I already showed you, right? So we need to check if the length is greater than 0. And if it is, we want to subtract the number of bytes that we actually, that shouldn't be called size. I think that should be bytes read. And that's what we want to do. Okay, and after that, we would like to actually return the number of bytes that we managed to read. That's great, but I don't like nesting. So what I could do here is to turn that condition around and say, like, if the len is 0, we return 0, and otherwise we just read bytes from the Wi-Fi client and return the number of bytes that we managed to read. Also, maybe that would be the moment to rename the len. So let's call it bytes left. Okay, bytes left. This is going to be the new name of that class variable. So it's, you know, more meaningful than just len. Great. So with this code, I'm pretty sure we can now have a very simple way of reading the body as a stream. Let me try to compile this again. Okay. One more thing, which I wanted to do last time, but I forgot, is to increase the number of the milliseconds on timeout on the clock. That needs further refactoring, but for now, let's just do that because, you know, I don't want to do the recursive loop again until the clock is set. So 60 seconds should be more than enough for the clock to synchronize. Okay, and now we've finished with SingleHostHTTPSClient. I consider it done, the refactoring done. And let's implement the actual solution now. So for that, what I want to do is, first of all, something that is needed to handle the response anyway. However, you know what? Let's move this callback to a function. So let's just create something like on request done, or on response, maybe something like this, on response, and that would be our function. We can pass it as a callback here. It just needs a pointer to a function, so no issue with that. Okay, on the response itself, we need to check for the error if it's not actually different to null pointer, because if it's different than null pointer, that means we have an error and we shouldn't continue. So I'm gonna do something like request error, and just print this error out. So let's do res error. Okay, and then return. We don't want to continue. If there is no error, that means we can read the body now. To read the body, what we have to do is to go, is to call the method available on the body stream. As long as it is available, we can now read bytes. But what we want to do is to write to the file straight away. So for that, I'm gonna have to initialize the file system and also open the file, which is going to be open the name of the file. This is the moment to define the name of the file. File name, let's just call it file.txt maybe, or maybe file read as stream. Something like that, to have a different name. Make sure, you know, we're not trying to overwrite something existing there that I've done yesterday. And we obviously need to pass it, and then a mode is going to be write. This is important, right? So we have write, and now inside the while loop we need a buffer, and that buffer needs to be a byte type, which is assigned int 8. Buffer, I'm gonna give it like 256 bytes. And apart from the buffer, I think this is it, because yeah, we've got the file opened. I could simply also check for the issue with the file. That shouldn't happen, but yeah, just to be on the safe side, could not open the file for write. You can do this and then return. That's fine. Inside the while loop, we want to connect the streams to each other, sort of, right? We want to simultaneously read from one stream and write to another stream. The stream we're gonna be reading from is the response stream. So I'm gonna do something like int, I think it's int, I'm actually not sure, so I'm gonna use auto bytes read equals to res body and read bytes, and that's gonna take our buffer, and the length is just going to be size of our buffer. This is not a char string, so there is not gonna be termination character at the end. And this is how we read it. I could actually print this out, so we'll see. So bytes read is gonna be bytes read. If bytes read is 0, we probably want to maybe also print it out. Something like could not read from the response body. This is an issue essentially if in between we cannot do that. So yeah, that would do this and then return. However, if I do return, I'm gonna have to duplicate my code on the closing the file and doing the end on the little fs. So maybe instead of printing it out like that, let me define an error. Let's give it 64 maybe. And that error is just gonna be copied to, so strcpy error. And that's what we're gonna do instead. And break. So we're just gonna exit the loop. Okay, so this is how we read the bytes from the body stream, and now we want to write to the file stream. And in order to do that, we just need to do file.write. And then pass, I'm pretty sure we could just pass the pointer to, yeah, we can just pass the buffer. And also the size of the buffer. So I'm just going to pass the bytes read because, you know, we actually not sure if this is gonna be 256 all the time. But bytes read, we essentially want to do that, right? We want to write the same amount of bytes that we read from the request body stream. So that's on the file. Also, let's call it bytes written. We assign it there. It would be nice to print that value out. Written, and then obviously bytes written, and that's gonna be quite similar. So let me just copy this and paste it here, and then it's gonna be bytes written. If bytes written is 0, then that means we had an issue with writing to the file, right? Could not write to the file. So that's our error. We're also gonna break, and this is the loop. So that's gonna, read and then write in a loop. We're not gonna run out of memory in that case. And after the loop, I need to close the file. I need to run the end method on the little fs to release the memory. And here, this is gonna be the place where I'm gonna first of all check for the error. So if error, you know what, maybe let's define an empty string, the error as an empty string, and only if it's not an empty string. So if error, we need to actually do strcmp compare. If error is different than empty string, we want to display something like maybe stream error, something like that. I have no idea actually how to call it. So yeah, let's do that. We just want to see it on the screen. And new line, I need to add the new line to this one, to this one. And this is it. The rest I think is fine, right? We got the new line there. Okay. Okay, and this what happens. And the last line, this is where we need to read the file. But for that, I'm going to add another function. I'm gonna call it read file. I actually prepared it beforehand because that's something we've already done yesterday. So if you are interested in the reading from the file and me explaining it step by step, please watch the yesterday's video. So yeah, I'm pasting it here. It is quite similar to the other loop. This could be actually 256 as well. And yeah, the rest is actually quite similar. But because we're operating on the text, there's this need for determination. Character. Okay, so read file is gonna be something that is called at the end when everything has been done successfully. Cool. Okay, maybe a quick walkthrough. And also for those who haven't watched the refactoring session, at least I explain how the code works. So everything happens in the setup method. We send the request. This is the path that we're trying to do. The host is defined here, right? So this is the 100 days of code S3, a text file, and we pass on the response function as a callback. This internally works. This internally uses the timer. So at some point when the tick is executed, that's actually gonna be executed, and there is all sorts of operation that's gonna happen for the request to be sent, like connecting to Wi-Fi, like synchronizing the clock, verifying the certificate, and once everything is done, it makes the request, and when the request is done, the callback is called on response, and that on response callback is basically evaluated with the response struct. Okay, if there was an error during all of this whole process of connecting to Wi-Fi, synchronizing the clock, and so on, we print out this error, right? There is one change that happened to response it does have a body stream. Instead, body stream type, body stream pointer to body stream object instead of a C string, a const char pointer. That was the modification I've done during the refactoring. So essentially, instead of reading everything at once and reading it to the string, this is when it happened before. We have another class called bodystream, and that bodystream basically extends the functionality of a Wi-Fi client, and it extends it to make it possible reading it easily as a stream like we do with the files. So just available method and read bytes. So yes, all sorts of things I had to do, essentially adapting this solution here from the Arduino IDE example to work as a stream. Very primitive solution though. If you want to have a look, have a look. So essentially for the available, we've checking if it's connected. There's additional check that happens. And also at the beginning, when the body stream is constructed, we operate on the size of entire payload, and that size is assigned to the bytes left class variable that is subtracted from whenever the bytes are being read, right? So when we read some bytes, is subtract the amount of bytes that has been read from that response body stream. Okay, it all happens here. Okay, yeah, that was just a quick one on how this works internally, right? Okay, so going back to the response that we take in the onResponse callback. If there was an error, we display an error. That's it, we're stopping. Otherwise, I initialize little fs, opening the file to write. The file name is file read as stream.txt. Then if the file couldn't be opened, an error, and then define an error C string and the simple loop that is possible thanks to the body stream class implementation. So we can just do res body available in a while loop, and we have a buffer. We read to the buffer, right? So that just reads the bytes from the body stream to the buffer. The size of buffer, the type is byte, and we get the number of bytes that's been read. We also display the information. If it was 0, that means there was an issue, like timeout on the connection, something like that, in between, like during the reading. And then we just, print out could not read from the response body. Then we use the buffer to write to the file, right? So we write the buffer to the file. We also print out how many bytes has been written to the file. And if it was 0, we essentially we print out the error. But it's not printed out immediately. It's just assigned to the error. Copied to the error variable that I defined before the while loop. And we break the loop, because we need to close the file and the little fs. So, having this sort of design, I don't need to duplicate the file close and little fs and on those, right? And then we compare the empty string to the error, right? Because if there was an error, we just want to print out the error. And otherwise, we read from the file. That's just going to read from the file. Great. Okay, I hope I explained it well. And now finally, one last check for the compilation, right? Cool, no errors. And I'm going to deploy now. Okay, serial monitor. Waiting for NTP time sync. Okay, let's give it 60 seconds, up to 60 seconds. It might be actually less. Let's see. Okay, that's done. Okay, we're getting bunch of messages, right? Bytes read, bytes written. We're getting the same amount, which is good. It is a bit slow, Maybe I should have put a smaller buffer, but yeah, let's see. Okay, that's done. Now we're reading from the file. Okay, I'm gonna have a look at the text now. Yeah, that seems to be okay. So great. So yeah, without all of this refactoring work, if you have a look at the main.cpp, this is pretty straightforward, right? I mean, there is still some, there is still some room for improvement, especially for all of those dependencies that have to be initiated here. I will try to figure something out. So, just the single host HTTP client will be required or something like that, maybe a factory. However, yeah, still quite straightforward. I've managed it to be. And yeah, this is how you read. This is how you download the files from internet on HTTPS protocol, which is the recommended protocol to use if you downloading something from the internet. If you work on your local network, yesterday's example is sufficient. You can just use HTTP. I would still recommend HTTPS, but HTTP should be enough. If you have a good Wi-Fi encryption, that should be fine. But yeah, for the internet, HTTPS, tomorrow or day after tomorrow, I show you how to initiate the HTTPS client with the certificate store. So this is gonna be a multi-host solution to call like any URL on the internet as long as the certificate is valid. And yeah, for today, this is it. That solution can be used with any type of files. And this is it for today. Thanks for watching. Tomorrow, I'm going to show you how to upload the file from your computer to ESP8266 using VSCode and PlatformIO extension. If you like my content and you want to stay up to date with my channel, hit that subscribe button so you will get notification as soon as I upload the next video. Thanks for today and see you tomorrow.